Welcome to a brief video on how to use, install, and operate Edgelake services. Edgelake is a set of data services that provides data lake capability without having to have a cloud to implement that data lake. It distributes those services across all edge nodes that are actually collecting the IoT data. So in a typical IoT environment, you would have edge devices. Sometimes they're as small as Raspberry Pi. Sometimes they're larger servers that are actually querying data from IoT devices such as machines, PLCs, cameras, etc. All of this data gets queried, and then in a typical IoT environment, that data gets pushed to the Amazon AWS or into Azure IoT. So that data gets pushed into a cloud so it can be queried and monitored. Edgelake does this a bit differently. So very similar to where I've got these edge devices collecting data, instead of collecting every bit of that data and then pushing every bit of it to the cloud, what Edgelake does is that it leaves a portion of that data at each and every edge, so that when I'm querying that data, I'm actually not querying a cloud. I'm actually pushing that query out to the edge, and each device that contains data that satisfies my query returns that data in parallel. So not only does it reduce data movement, because I don't have to move each and every record to the cloud, it also scales query performance and insertion performance at a much, much, much higher rate. Insertion performance is improved because I don't have to push that data to the cloud, which is actually the slowest of all the processes. Query performance is improved because I get to distribute my queries across all devices that contain that data. So I can literally have 1,000 devices returning data instead of one database running in the cloud returning that data. And we'll go into more detail in just a moment. So in a basic deployment, you have three basic Edgelake services. One is called an operator. An operator is used to actually store data and pull data from the edge devices. You have a master or a blockchain. We'll go into more detail about that in just a moment. And you have a query. That is a particular service that is used to actually distribute queries across all of the operators that actually contain the data in an AnyLog or an Edgelake network. We'll go into more detail as we move forward. So we have these operator nodes. You could have one up to thousands of operator nodes. In this example, we're only going to be using one operator node as part of the deployment scenario. Each operator node is then connected to a blockchain. The blockchain is used to synchronize data, to synchronize services across all of the different operator nodes in an environment. So you could have 10,000 or less devices in any Edgelake network, and that blockchain is used to synchronize the data between all of those services. The blockchain is not used to store the data. The blockchain is used to synchronize the data. The blockchain is a little challenging for some customers to implement due to complexity. So what we've also included as part of Edgelake services is something called a master node. And a master node is effectively a blockchain in a box. It allows us to offer blockchain services on a single machine to support the synchronization of all the operators Edgelake operators in an environment. And then finally, we have the query node. A query node it orchestrates queries. A query node leverages the blockchain or the master node to understand what devices and what data is stored on what devices out there. And then so when an application needs to query that data, it goes to a query machine. That query machine could run on any one of the machines in the environment. So any operator, each machine running edge operators could actually also run a query as well, or you could have dedicated query machines. But the beauty of it is that once an application requests a query, that query, because it understands where the nodes can satisfy that query, will distribute that query to could be thousands of nodes in an environment. So at that point, that query is then returned in parallel. So each node that actually has the data returns the data in parallel. So I'm not depending upon a single instance of a database to turn it. I could literally have hundreds or thousands of devices returning data simultaneously. So my query performance is extremely, extremely quick compared to a cloud-based data service. Again, query nodes can be connected to by any BI type of tool, such as Grafana or Power BI. In this example, we're actually going to be using an example of how to return data to Excel. Now that we've introduced Edgelake services, let's spend a few minutes on talking about how to deploy Edgelake in your environment for testing and other aspects. To deploy Edgelake, we would go to github.com/edgelake/docker-compose. That contains all of the instructions and prerequisites needed to install Edgelake on the various operating systems supported by Edgelake. In this case, we're going to be deploying on Ubuntu. So we're going to go to the directions for the Ubuntu. There is a very simple script that is used to deploy all of the prerequisites needed for Ubuntu. You can simply copy those prerequisites, go to your Ubuntu shell, and paste those prerequisites in. So that will download and install all the prerequisites needed for Ubuntu to support Edgelake services. You notice that we support Ubuntu, CentOS, SUSE, Red Hat, and Debian Linux distros. So there are instructions for all of those distros. Now that we've installed the prerequisites, we can go and actually install the software needed for AnyLog. Start by copying the data and then pasting it into the window. AnyLog install scripts have been downloaded and is ready to install. If we do an ls, you'll see that we leverage a makefile. That makefile is used to do all of the heavy lifting for the installation procedure. If we type make, it'll list the different attributes that the makefile supports. You can build a Docker image for each of the services. You can download and install those images using the up command. You can attach, so each service that AnyLog supports or Edgelake supports has a console. So you can literally attach to that console and run commands in a distributed way, very similar to what an, a network operating system provides you. I could go to each device that provides the data services, each operator node, each query node, or even the master node, and I could run from a command line all the services needed to support the distributed environment. You have the ability to shut those services down using the make file. You have the ability to look at the log files for those services. You can delete and remove those services with clean, and then obviously the help message. So in this case, we're going to begin the installation of Edgelake. So now that we've started the Edgelake services with type master, it is actually downloading the Docker images and then Docker containers from the web. This takes a few moments. And it's complete. We can use the make file to ensure that the Docker image is running, the master is running. So we could do a make logs master, and we can see that the logs for the master are already there and the services are running. We now need to install the operator node. Again, we'll just use the make file. We're going to up, which will install and enable those services, and we're telling it of type operator. Since the services have already been downloaded earlier by the master, it's much faster this time. So again, we're just going to check the logs for the operator to see if those services are operational. And again, we see that they are running and operational. Finally, we're going to install the query node. It is complete. So we're going to quickly check the query services to see if they're running, and indeed they are running. So we have physically downloaded and installed all three operator, master, and query services on a Linux box. We can check the status of those services by using a standard Docker command called Docker PS, and you can see that those services are up and running and successful. So Edgelake is installed and operational. The next step we're going to do is connect to a query node and to run some of those commands we talked about. I said that there was a CLI based on each node. Well, we're going to connect to that CLI and run a couple of very well used commands so that you can understand how this will work. We'll run make attach query, and you'll see that we're got our prompt that we are an Edgelake query node. Now there's a variety of commands that we could run to check things. One of the most common commands we use once we install Edgelake is a get connections. Get connections will return the ports being used by that service and the IP addresses that the service is bound to. In a device that has multiple IPs, you can have multiple IPs replied to this, or I can bind it to a single IP in a particular device. But in this case, we can see our internal and external IP addresses and the ports used for this particular service. Now that we've installed the software, now we're going to show we talked about the command line supported on Edgelake. We're going to connect to one of the services in that to show how that command line can be used to query all the devices in Edgelake network. By using our make file, we can run the attach command. The attach command will then attach itself to the query service and access its command line. There's a long list of commands that can be run on that command line. It's a rich set of services that you could run on any edge-based device collecting data. So I invite you to look at the documentation. We'll talk about the documentation at the end of this discussion. So you can go and look and see. But again, if I just type help, you can see all the different commands that are supported. We're going to go over some of the most basic commands as part of this discussion. The first command we're going to go over is get connections. This is used when I would need to determine what ports, in this case, this particular service, the query service is running on port 32348 and 32349. You also can see which IP port these services are bound to. In my internal network, you can see it's bound to 192.168.1.218. So this is a diagnostic tool that you could use to determine a variety of things. The next command is a test network command. Test network will actually query the entire network. And remember, when we installed, we only installed 3 services. But in a larger installation, it will query all of the operators that are out there and show whether or not they are connected successfully and synchronized using that master or blockchain that we described earlier. So if I need to check to see what services or what attributes are running on each of these services, I run a get processes. You could see, the different types of attributes that we support, things like MQTT, message broker. These are all data services that are built in and standard inside of Edgelake. gRPC, Kafka, all of these are standard services running inside of Edgelake. I can enable or disable them via the command line, or I can do it at installation time. Another command that is used is streaming. So as data is finding itself into the Edgelake services, you could monitor that data in real time using the get streaming command. You can see how many rows of data is being called and inserted at any one point in time. So leverage make streaming to determine data is actually making it into the Edgelake environment. You can also check to see what databases are installed. So Edgelake will automatically install databases for you. There's a variety of databases that are supported out of the box, such as Postgres, SQLite, and using scripting language, you can basically support any database you want to at the edge. In this case, for our sample, we're using a SQLite installation that was installed automatically by the installation procedure that we did. Again, you can use whatever database you want, but by default, it used the SQLite. And you can see that we've got a couple of databases that were automatically created based upon the data flowing in. Alarm data and a new company data. Another useful command is data node. Now, this is not as useful in this particular environment because there's only one node ingesting data. But if you look at when you have multiple nodes or hundreds of nodes or thousands of nodes ingesting data, get data nodes will show you essentially where that data is coming from, what database it supports, and what tables are loaded on that particular device. So it's very, very useful to determine what will report or return data back from your query. The next command is get virtual tables. So virtual tables will actually query all of the data on all of the nodes and return the logical version of the table. Remember, that table is not stored on one node. That table could be literally on hundreds, if not thousands of nodes. So it aggregates that and returns the databases and the tables associated with that. The next command is a get columns command. This is a very useful command when you don't really know what columns of data. AnyLog or Edgelake is intelligent. It understands based upon the data that it ingests and dynamically creates data tables, rows, and columns. So I don't have to have the knowledge of what to create on my columns of data automatically. Edgelake does that automatically. So if you want to see, if you want to see what those columns are, you can pull those up automatically using the command. Finally, we're going to run a query. You'll notice that the query is very SQL-like. I am doing a SQL command. I'm telling what database, as we can see from above, which database it is. I can format the data into CSV, into a table, or into JSON data. And then I begin my standard query. I'm selecting timestamp and value from table ran data where the timestamp is less than 30 seconds old. Now you'll notice there's this interesting run client and an open and close curly bracket here. What we're doing is this is one of the power of Edgelake in a distributed environment. What run client will do is essentially find all operators in an environment, every single one of them, and will run this command on all operators. So it returns from all the devices out there. And now I see all my data. And the final command we're going to run is get error log. So if you ever need to look at the error logs, you could actually look at get error log and show what failed in the last time. So we have gone over the installation of Edgelake. We've gone over how to install it, how to run various CLI commands on Edgelake. So those are all complete. The next thing we're going to do is another interesting capability of Edgelake is that anything you can run via the local CLI, you can also run via a web service call. Now we're going to run some of the same commands that we did on the CLI via a web service call. You can see that here is my IP address and the port of 32349. This is the same port we saw when we did our GET connections. All we're doing is running Postman, standard Postman. We're running a GET command against the URL, which is the IP address and the port in question. The two headers that we need to add to that is command. The command will contain the actual command that we're running remotely. And then the user agent will always be AnyLog/123. Just for your edification, AnyLog and Edgelake are very similar. AnyLog is a commercial product that is available from AnyLog Corporation. Sometimes you'll hear me use both terms, AnyLog and Edgelake, together. Edgelake is an open source version of the AnyLog commercial product. Many of the commands are the same. AnyLog does support a superset of capabilities that the Edgelake product supports, but you'll find that wherever you see AnyLog, most of the capability is also in Edgelake. All right, let's run that command. You see, this looks very similar to the command that we ran directly from the command line. We're going to run a test network. Again, something that I can run remotely and get the same results as if I'm running on the command line. We're still connected. The most interesting one is let's run our query remotely. Now, there's a little bit difference. Instead of run any, like we saw, a client like we saw in the CLI, it's a little bit different format. So what we're doing now, we're using a destination key in our headers, and that destination says find all devices in the network. We could also select a subnet. We could put in a single IP here, or even a list of IPs to specify a destination. But in this case, we're specifying all. And in our demo environment, that's one machine. So we could run our query. And you see the value of data that it's returned. Very similar to what it returned up here. The final thing we'll talk about is documentation. You can reach the AnyLog documentation at github.com/AnyLog-co/documentation. It has a long list of how to run all the commands, whether they're CLI or web-based commands, querying the data, HA, southbound connectors, northbound connectors, sample codes, etc. All of that data is available via the documentation page. At this point, we're complete. Thank you for joining the video. Good luck with your Edgelake install,